Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good. So, how's your review going on mathematics?
Um, Yeah, all right. I think especially for year 13, which I'm currently in, it's kind of a lot of exam questions. Like I spend day in, day out doing that for all my subjects, and kind of reviewing all of year 12 content. And then obviously it would follow through for year 13. So far, the stuff I'm learning in school, I've been all right. So I've been reviewing other topics. But as soon as I start learning new stuff in year 13, I'll have to kind of put that exam stuff aside. So it's really good that we do those little like catch ups, with these lessons here when we pick some topics like whether it be logarithms, some calculus questions or circles, like just picking a couple exam questions from each of these just kind of keeps my mind, refreshed about these different topics and formulas and stuff and ways of solving.
Yeah. So, today, what do you have for me?
I've got a couple exam questions, and this is kind of a variety. So, like, it comes from my exam board, which is Edexcel, and I guess the people that is kind of aimed at is towards year 13. So, sixth form, that will be in UK. So that's how it works. The other extra 2 years, year 12 and 13, and it's just all kind of working towards our end of exam, which is our A levels. At the end of year 13, we'll have the exam, which is combining our year 12 content and year 13. So, yeah.
So, if I compare it globally, I see that international students who seek admission in UK and they go through IGCSE, this is International Cambridge University exam.
Mm-hmm.
For them, it is a level A test paper which we are working on. So, and equivalent to class 11 or 12 in many parts of the world. Here in Canada and US, this is equivalent to grade 12 or sometimes grade 11 if you're doing IB curriculum, or if it is AP Maths, in that case, grade 11. So, all grade 11 and 12 students should be in a position to understand what we are talking about,
Right.
and it should definitely help them to prepare better for their own exams. So
Yeah,
in
definitely.
examination, you can see there are like 10, 20 questions. What we are
Mhm.
focusing on is the variety and normally the questions where students really need help. So as Amy was saying, we'll take 4 or 5 examples, one of each kind, covering trigonometry, logarithmic and exponential functions, circles, and calculus, which will be derivatives and integrals. So,
Yeah.
Amy, please share, as you have been doing earlier also, today's questions with us.
All right. So yeah, I've never seen these questions before. It's good to go in like completely like without any kind of known about the question, which is good.
Good. So, can you please read the question?
Yeah. So a trading company made a profit of 50,000 in 2006 in year one. A model for future trading predicts that profits will increase year by year in a geometric sequence with common ratio R being greater than 1.
Correct.
The model therefore predicts that in 2007, year 2, a profit of 50,000 R will be made. Part A, write down an expression for the predicted profit in year N.
Okay. So, how will you do it? What will be your expression for the profit?
So I know it says geometric sequence, and usually the formula that we use for that is, when you're trying to find the nth term, it's a to the power of AR n to the power to the n minus 1. And that's like how it usually is. But in this case, because they're saying that n is the year, won't it simply just be 50,000 R to the power of n, like without the minus 1? Because let's say you substituted n as 2, we know year 2 is 2007, but if you did n minus 1, so 2 take 1 is 1, you're going to get the value for 2006, so it has to be to the power of n.
Correct. So, let me define n properly. What we are trying to say, as per the question, is when it says that the trading company made a profit of 50,000 in 2006, which is year one. So that means
Yes.
N is year since 2005, right? So if N is 1, you are in year 2006. You get the idea.
Yeah.
So when I say of course, the profit will be made at the end of the year. So trading company made a profit of this much in 2006, the whole year. So 2006 N is 1, and that matches with 2007 as year 2. So first thing is we have to define very clearly what is N, correct?
Okay. Yeah.
Now, it also tells you one more thing. That is, in this particular statement, let me just put it in a box. Can you please read this once again?
The model therefore predicts that in 2007, year 2, a profit of 50,000 R will be made.
So it is 50,000 R. That means if I put 2 as the value of N, I should get 2 minus 1, which is R. So the formula works for us. You get the idea?
Right.
So we know here A, initial value, is 50,000. That is the profit in the first year, right?
Yeah.
So now we know that P, in general, the equation will be equal to 50,000 R to the power of N minus 1. So when I put 2, which is the profit in 2007, it is going to be 50,000 R to the power of 2 minus 1. Do you see that? So which is same as 50,000 R to the power of 1, which is R, right? So that confirms the statement where it is written that in 2007, which is year 2, correct? Which is year 2, we have a profit of 50,000 times R, correct? And every year it will be times R, times R, times R, because it is a geometric series, right?
Right.
Correct. So we have done part A, which is write down an expression for the predicted profit for year N. So the expression for year N will be that P of
50,000
N is equals to 50,000
R to the power of
to
N
the power
minus
of
1.
N minus 1. Correct? So that is our part A, right? Now again, please continue.
Okay, so the model predicts that in year N, the profit made will exceed 20,000. Part B, show that N is greater than log 4 over log R plus 1.
Correct. So now we have to solve this particular equation, saying that profit will be exceeding 200,000, right? So we want this value, which is 50,000 times R to the power of N minus 1 exceed 200,000, correct? So we need to solve this inequality basically. Is that clear?
Yeah.
And they have also given us the solution. So we need to just verify the result. So that's the beauty of your test. They kind of help you out to solve problems, right?
Right.
So I like this part. So but it is more concept based. So basically, I think it helps you understand the topic better. And this way, you actually get prepared better for your own exam, because you're going through the proper steps. So, Amy, can you please solve this? We'll divide both sides by 50,000.
50,000.
So we have R to the power of N minus 1 greater than 200,000 divided by 50,000, which is 4, right?
Yeah. And then take logs on both sides.
Then we take log on both sides. Let me change the ink since it will be very messy by the time we end. So we'll take log both sides. So when you take log both sides, R to the power of N minus 1 equals to log of 4. It will be N minus 1, right? Log of R equals to log of 4. So N minus 1 equals to log of 4 divided by log of R, correct?
Yeah.
And therefore, N is equal to log of 4 divided by log of R
plus
1. And that is, I think, what is written here, right?
Yes,
so
it is.
It's slightly messy, but I hope you understand the concept. Here we are there to give you the concept in the best possible way. So that's the question, and this is how we should attempt to solve it. Amy, is it clear to you?
Yeah, very clear.
Can you explain what we did?
So we first we read what the statement said, and it's saying that the profit will be exceed 200,000. So when you see, usually my exam board, it has a lot of these like exceeding and everything, and the use of inequalities. So all we did was make our like equation from part A, greater than 200,000, and basically we're trying to get n as the subject. So as you follow through it, like any algebraic equation, we divided both sides by 50,000, and then we got r to the power of n minus 1 greater than 4. So then we took logs on both sides and then got the value of n, which was required. Yeah.
Correct. So Amy, write down these formulas, because for part C and D, we might just need them, right?
Yeah, I did.
And then I'll erase the screen. You have written, right?
Yes, I have.
So let me just clear the screen. Now, can you read further?
Yeah, so using the model with r equal to 1.09, part C, find the year in which the profit made will first exceed 200,000.
Okay. So you can plug in r equals to 1.09 and calculate the value of n, right? So,
Yeah.
so if I do it, and then we'll just figure this out. So n is greater than log of 4 over log of 1.09
Plus 1.
So what do you get?
17.086.
Right. So we have defined n as years since 2005, right?
Right.
So now, so it says the model predicts this profit. Using this, find the year in which the profit made will first exceed this much. So 17.08 means if I add 17 to 2005, that will not be the year. We have to add 18, correct?
18. Yeah.
So that means n equals to 18. So now we can add 2005 plus 18 and get our year. You get the idea?
Yeah. So 2023.
It will exceed this. So this year will be 2036. That is why it was very important right in the very beginning to define what n is. N is years since 2000, right? So
yeah. So do you think?
Yeah.
Do you think people make the mistake in adding 18 to 2006?
Yes.
Oh, okay.
Because see, if I take n as 1, right? So 2005 plus 1 is 2006, correct?
Yeah.
That means the first statement is correct. So therefore, I have to add it to 2005, not to 6, correct?
Oh, right. Yeah.
So very important. At the last minute, you can actually make this mistake.
Right.
So
can we check this value by substituting into the equation of part A?
Yeah. So just plug in 18 in your equation C. You will get much more than 200,000 because that was 17.08. So,
okay.
But if you put 17, that will be better check. It should be less than 200,000. So,
okay. So let me put
the value
17.
of R as this and check 17. So we have 50,000 times, what was it? The equation?
1.09.
1.09 to the power of n minus 1. So 17 minus 1 is 16, right?
Yeah.
Calculate this.
Yeah.
How much you get?
So I got 198,515. So yeah, less than 200,000.
You see that? So therefore, our value of 18 works, right? Because if I write this as 50,000, 1.09 to the power of 18 minus 1, which is 17, right? Now calculate this.
Yeah. 216,381.
You get the ideas, right? So that is the check, and which confirms that you should add 18 to your result.
Oh, I see. Yes. Yeah.
Right.
Okay.
So that is find the year in which the profit made will first exceed. Now, can you read part D, please? I'll erase all this now, okay?
Okay.
Right.
So part D, find the total of the profits that will be made by the company over the 10 years from 2006 to 2015 inclusive, giving your answer to the nearest £10,000.
Okay. So when we are including these years, how many years are there? See, so we do 2015 minus 2006, correct? What do you get?
+1. Oh,
plus
9.
1. Yeah, when you minus, you plus 1, right?
Right.
So let me plus 1 first. So it is 2016 minus 6, right? So
yeah.
that means 10 years, correct?
Yeah.
And that is what the question is saying. Find the total of profits that will be made by the company over the 10 years. You get the calculation?
Oh.
Inclusive means you have to add 1 after subtracting. That is also a common mistake which is seen in test papers, right?
Yeah, I've seen so many questions like this when they say inclusive, and then you forget to add that
Add one.
one on.
So
Yeah.
these are small things. Even after doing it correctly, you get a wrong answer because of wrong interpretation. Is that clear?
Right. Yeah.
Okay.
Part D. Find the total of the profits that will be made by the company over the 10 years from 2006 to 2015 inclusive, giving your answer to the nearest £10,000.
Clear to wrong. So basically, we now know that it is a geometric series. So now we are using this as a geometric series, correct? Where A, the starting term is 50,000.
50,000. Yeah.
Correct? And then it is 50,000 R and continued, correct? So in this series, we have 10 terms where A value is 50,000 and R is given to us as 1.09. Is that clear? So what is the
so we're using, okay, yes.
geometric sequence formula, right? So when, okay, let's understand. Geometric sequence is just the numbers one after the other. But when we say geometric series, it is the sum of these numbers in the sequence. So that is one distinction between geometric sequence and geometric series. Is that clear to you?
Oh, so sequence is the numbers, series is
sum
the
of those numbers.
Addition of those numbers.
Addition.
Okay.
Right? So now,
Just write that down.
remember the formula. What is the geometric sequence formula?
I'll be honest with you, I don't remember it, but I got it down here. So a to the power of, oh, you're doing that one. There's two, but yeah. A to the power of 1 minus r to the power of n over 1 minus r.
So I have written it correctly, right?
Yeah.
Perfect. So that is the formula. And we know it is 10 years. And we know the value of A. So substitute the value of A, which is 50,000. 1 minus 1.0509 to the power of n, which is 10, over 1 minus 1.09. So when the rate is higher, we normally write r to the power of n before 1. Normally we write that, right? But here, both negatives will become positive. So you get an idea what I'm trying to say. So normally you write this formula as the same formula. So we'll switch the places, right? So we'll write, normally we could also write this as a r to the power of n minus 1 over r minus 1. Both are one and the same thing, correct?
Yeah.
But you know, when you use calculator, it is better to write so that you get a positive number, right? Because too many negatives sometimes make a problem. So now if you calculate using this result, it will be better for you. So can you please tell me what is the sum?
Yeah. 759,646. So they want the answer to the nearest 10,000. So 76.
760,000.
7. Yeah.
Correct?
Yeah.
So we have to round it to 10,000. So it will be 10,000, 20,000, 30,000. In this case, 60,000 as your rounded number, right? So 760,000 is the answer in pounds. Is that clear to you?
Yes. Yeah.
Perfect. So that is how this question should be solved. So, Amy, can you summarize critical things which we should keep in mind while solving such a question?
Yeah. So for part A, because in the question it stated that this model is in relation to a geometric sequence, it's all about defining n and knowing our formula as it is AR to the power of n minus 1. We try to use the similar approach, and when we substituted the values given to us, like year 1 is 2006 and year 2 is 2007, we found out that that is the formula to predict, to understand the predicted profit. Then part B, it's to do with inequalities. So simply making the formula we just calculated, making it exceed 200,000, and then working through as an algebraic equation, and then taking logs on both sides. Part C, the main part was to substitute in our values all given, because from part A, when we defined all our variables, it was quite straightforward to like put A as 50,000, R as 1.09, and like that work through. But the main thing for part C is once you calculated your values, just to double check, it's really good to substitute the value of n you've got into your equation to part A, just to check that does your value exceed 200,000, because you might think it's another step, but it's that one step to make sure that you've got your answer right, and it takes 2 seconds. So I definitely recommend to do that.
Perfect. So these are very important things. You get the answer. Everything is given to you, right? So everything is given to you. You just need to use your calculator once again and check your result. Do not forget to do that, and then move forward with the next question. Correct? So let's move forward.
Okay. Let's see. So yeah, this is a bit of binomials. I think this will be kind of straightforward, so I think I'll just skip that one. Okay. Let's do a bit of integration calculus.
You wanted to do calculus today. That's very good.
Yes, I did.
Please read the question. Yeah.
Okay, so figure 3 shows a sketch of part of the curve with equation y equals x cubed minus 8x squared plus 20x. Part A, use calculus to find the x coordinates of A and B.
Correct. So let's do part A. When you say use calculus to find x coordinate of A and B, so A and B, as you can see from the graph, are actually what?
Turning points.
Turning points, which you also call, turning points. Local maximum.
Stationary points.
Stationary.
Oh, okay.
Yeah. You got so many names, right?
So many names. Yeah.
Right. So only we also call them critical points, right? So, so A and B, so you can see A and B are turning points. That is simple. So that means at these turning points, the derivative will be 0, right?
Right.
So whatever the function is, the derivative of the function will be 0. So we call this as a critical number, right? So that's a small review on this. So basically, to find the x values of A and B, we just need to find the derivative of the function, which is y equals to x cubed minus 8x squared plus 20x. So the derivative will be dy dx is equal to 3x squared
3x
minus
16x plus 20.
Plus 20,
Plus,
20, plus 20. We have to equate that to 0 to find the critical number. It's a quadratic equation. Can you please find the solution? So we have 3x squared minus 20x minus 16.
So you're going to multiply it.
Equals to 0. You can do product and sum. You can use the quadratic formula. So we're looking for two numbers whose product is 60 and whose sum is 16, right? So basically, let me do it on the side. So we're looking for 3 times 20. So 16 is the sum of these two numbers. So you can split this and write as 4 and 5. So if I use, and both should be negative, right? Same sign, correct? So what could be those numbers?
X minus 2.
So if you use 6, do you see this combination? 3 times 2 is 6 and 5 times 2 is 10. So that really helps. So we are going to use this and factor this. 3x squared minus 6x minus 10x plus 20 equals to 0. Well, you can use the Australian method of factoring also, but we'll go very systematically, so which is convenient for all the students. So amongst this, 3x is common, right? So we get x minus 2, and here 10 is common. You get x minus 2 equals to 0. So we get x minus 2 times 3x minus 10 equals to 0. So you get 2 points. One is x equals to 2, and the other one is x equals to 10 by 3. Is it clear to you?
Yeah.
So which one is A and which one is B?
So A is x equals 2 and B is 10 over 3.
So these are the x values which we have just figured out. So make a note of this. I may erase the screen, okay? So all of you can make a note of this. So use calculus to find the x coordinates of A and B. So we got the x coordinates of A and B, correct?
Yeah.
What is part B?
So part B is find the value of d squared y
Second derivative,
over,
d2y over
oh,
dx.
that's how I say it. Sorry, dx.
d2y over dx squared at a, and hence verify a is a maximum. You get the idea? So,
yeah, so second
question
derivative.
is helping you out, but actually, strictly speaking, you should do it on your own also.
Oh,
If it's not asked in the question, right?
yeah, yeah.
So, yes, we have the derivative, which is 3x squared minus 6x plus 20 equals to 0. Let's find the second derivative for this. Okay, so let me use another ink here, and let me write d2y over dx squared. Can you tell me what is that equal to now?
So 6x minus 16.
So we get 6x minus 16 as our second derivative. Now it says, hence verify that this is a maximum at x equals to 2. So if I put 2 here, do I get a positive or a negative value?
Negative.
Correct. So d2y over dx squared at x equals to 2 is what? 6 times 2 minus 16, which is 12 minus 16, which is minus 4. Since it is less than 0, we know the concavity is concave down, right? It is concave down, and therefore, this is a maximum. Is it clear to you? So that is how you will explain and write down the solution for part B. Is this clear to you?
Can you also explain it by, so let's say, wait, you subbed in the value of 2.
Yes, because we have a derivative. We have a derivative.
I was thinking of, your method where you choose 2 values on either side of 2, and then you look at the concavity.
No.
Can you do that as well?
No. Oh. That you do when you have a boundary condition. So in case the boundary is fixed, then at the critical number, you find the value of the function and also at the boundaries. And then you just compare the critical number value and the boundary values to decide whether it is maximum or minimum.
Oh, so you can't put in like 1.9 and 2.1?
No, we cannot. Here you have to find the second derivative. Okay. If second derivative is negative, that means it is concave down, you have a maximum. If second derivative is positive, it is concave up, you have a minimum. So that gives a very good test for the testing critical numbers as maximum or minimum.
Right. Yeah.
Okay. You could do using the first derivative test also. That is, we could use this and say, well, it is increasing and decreasing what you're trying to say, right? One value, you say it is positive, it's negative, but that is your first derivative test. Question is specifically asking for the second derivative. So we will not use that method which you were talking about. Is it
right? Yeah. That's clear.
Yes. If it is not specified and if you're doing on your own, then yes, I mean, you can do what you were saying.
Oh, I see. Yeah.
Analyzing the first derivative. Yes.
Yeah, because I do think we have questions like that, some 11 markers or something where they will just ask, is it a maximum? So it's quite open-handed. Yeah. Good. All right.
Just so this part is absolutely clear. So I'll erase the screen now. You made a note. Important thing to note is these 2 points, x equals to 2 and 10 by 3. Okay. So I'll erase the screen and write down quickly. This point is at 2 and this is at 10 by 3. Now, please read the question further.
Oh, sorry.
Okay, let me.
I'll move it back up. Okay, cool.
Right. So, okay, this is 2 and this is 10 by 3. Okay. Yeah.
So the line through B parallel to the y-axis meets the x-axis at the point N.
That is a vertical line. Vertical line as shown here.
Here.
So x equals to 10 by 3 is N. Right. Continue.
Right. The region R shown shaded in figure 3 is bounded by the curve, the x-axis and the line from A to N.
Correct.
Part C, find the integral of x cubed minus 8x squared plus 20x dx.
Correct. So that you can find, right? So Amy, can you give me the result? Integral of, let's find this integral, x cubed. So we'll use the power rule, correct? And figure this out. X to the power of 3 plus 1, which is 4 divided by 4. And then we have minus
8x cubed over 3.
And plus
20 x squared over 2.
This could be written as x to the power of 4 over 4. minus 8 over 3x cubed plus 10x squared. Correct. So we should write
Plus
plus.
C.
Correct. We should.
Yeah.
That's very good. You have to write plus 6c, right? Because the family of curves, which will give you the same derivative, and therefore, when you're doing the reverse of it, you have to write a constant. Correct.
Right.
So we've done part C, including constant is a must. Okay. Now, what is the next one?
Oh, yeah. I actually remember we had that mocks, and so many of my classmates lost marks just because of the plus C. It was such an annoying mark to lose. So, like, just put it down. Yeah. Okay. Part D. Hence, calculate the exact area of R.
Perfect. Now, this is the most critical question, and also it has marks, 5 marks, right? After doing all that, right? Now, tell me, how will you find the area which has been shaded here? Amy, what is your thought about this?
So, my thought is, see, the thing is, you're forming a, so I was going to make a triangle, and I was thinking, so you have to do it from 0 to 2.
So,
and then
so
2
the
to
area,
10.
you're right. So that is what you have to do. So you have to find integral from 0 to 2 with this equation, which is x cubed minus 8x squared plus 20x, correct?
Yeah.
Dx. So you get this integral, so you get that area. Is that clear to you?
Yeah.
And now you have a triangle. So you add to this the triangle area, right? So we'll add from 2 to 10 over 3. Do you get the idea? 10 over 3, right? The triangle area, which is half base into height, right? But we have to use integral. Now, what is the equation of this line? So you have to find the equation of the line which goes through these 2 points. You get the idea?
Yeah. But just a quick thing. Wait, when you find the between 2 and 10 over 3, we're not using the integration formula, are we? Or are we?
That's brilliant.
Because you're going to get all the area under the graph. Yeah.
That is brilliant. So what you could do, I will not suggest, but you could do, that is, you use the first part integration under the curve, right? Then second part is just the triangle.
Triangle, yeah.
Into height, right? So this, you could use this formula, but you have to write the equation of line. You get the idea?
Right, yeah.
Otherwise, you can say this triangle, which is right there, has a value which is base of 10 by 3 minus 2, right? This is 10 by 3 minus 2 is the base, correct? And the height is the y value of the function, correct? At 2.
At 2, so you just substitute, 2 into f of,
And you know this area is half base times height. Do you see that? So you get this area and add this up here. So you find the area under the curve using the integral, and then use the triangle and use simple geometry or algebra, whatever you may call, to find the area of this portion and add them up. You get the idea?
That's what That's why I was thinking, because for between 2 and 10 over 3, if I just did the integral, you can get also that white space, and we don't want that part. Yeah.
So integral is not to be done. But if you want to use integral for your solution, then
how would you
first find the equation of the line. So let's find the equation of line and put this in integral. Okay, I mean, it's a difficult thing. It's important to remember and learn. In this particular case, you could find the area directly also, because we have a right angle triangle, easy to find area. Is it okay? Now, let's find the equation of line AN. So what is the slope of AN?
So we have to do change.
We have to find. So in this function, let's figure what is the value of f of 2, right? So we have to find f of 2 in any case. So you write this as 2 cubed. Can you please calculate 2 cubed minus 8 times 2 square plus 20 times 2, which is
56.
Oh, you got the answer. Okay, which is equal to 56, right? So the y value is 56. So what we are expecting area as, so 56 is your height, right? So hello Dheeraj. हाँ बताओ 1 मिनट. हाँ क्लास चल रही है, तुम थोड़ी देर मिल लो, अभी 15-20 मिनट की क्लास और बची हुई है. Okay, bye.
Sorry, so the value was 16. My bad. Sorry.
Which value was 16? Height?
No, not 56, 16.
Oh, okay, sorry.
Yeah.
So, right. So, so Emmy, what is this value? 16? You said what?
Yep, 16.
1, 6. Okay, 1, 6. So, yes, you can confirm this. This is minus here. 4 times 8 is 32. So, 8 minus 32 plus 40, correct?
Yeah.
So, 48 minus 32 is 16, correct? So, that is the value for the height of this triangle. And what is the base length? 10 by 3 minus 2?
4 over 3. 4 over 3.
So 6, 10 minus 6 is 4 over 3, right? So we can find the area using the triangle. So let me write down that area equals to half of base, which is 4 over 3, times the height, which is 16, right? So let's calculate.
Yeah. So we're doing area of the triangle. 16 divide, no, you did not. 32 over 3.
32 over 3. We are not trying to find the equation of line and do all that integral. So we kind of cancel this part and we'll say we'll add area of triangle here, right? So we'll add area of triangle, okay, which is calculated as 32 over 3. Is that clear?
Yeah, yeah.
Okay, let's find this integral, which we already have here. This is the integral, correct? So let's put the value. Let me use the different ink again. Let's put the value, which is x to the power of 4 over 4 minus 8x cubed over 3 plus 10x squared. And this goes from 0 to 2. So find the value at 2, and we'll add this 32 over 3 to this. Please find this. So I'll prefer all the students to actually do it on their own, right? There could be some calculation mistakes. However, I think you have understood the method of doing it. And I also encourage students to find equation of this line and then use integration to find the area. So what do you get?
68 over 3.
68 over 3.
Yeah.
Total area or that area?
Oh, no, just the area of the
okay, so we'll add these two. So we'll add this. 68 over 3 plus 32 over 3. What do you get?
100 over 3.
Wow, what a number. So good. So that is the answer for this particular question. We say we got this area as 100 over 3 square units. Okay. So unit
So
square.
just a quick thing.
Yes.
You know, on these scientific calculators,
yes.
You know, this integral button, you know, the integral button there, like the F1, when you press that and you put like 2 and 0, what do you put the equation as x cubed minus 8x squared plus 20x, or do you put the equation of x to the power of 4 over 4?
No, integral equation. So because you do the integration and then find the answer. So the calculator will do the integral and then find the answer.
Oh, I see. Okay. Do you think it's just better to substitute it into the integral equation you calculated because it's just safer?
See, graphing calculators are not allowed in the test. So remember that part.
This is not graphing. It's just a scientific calculator.
Okay, but they would like to see all your steps. Well, some of you are using that. You could use to check your result. Yeah,
I think this is 5 marks, so they do require working. I just mean as a double check.
Double check you could do, yes, of course, right.
Okay.
You could do double check, right? But strictly speaking, if it was a examination and invigilator was there, they would not allow you to use integral on the calculator, because these days calculators are very powerful. They can give you all the results.
Right? No, honestly, the amount of times we've had this debate in school, because only some students, because these graphing calculators are like £100, £200, like 150 or something, and none of all of us can afford that, right? So they obviously got an advantage over us. But I do think showing all the working is obviously more, you're going to be better and you're going to be more accurate. So it's just,
Don't rely on your calculators alone. Sometimes the invigilators may not allow you to take the calculators. These
Really?
kinds of, there's a restriction on calculators. It's very
Oh,
clearly written that graphing calculators are not allowed for this test. Very
oh, right.
clearly written, yes. So if your calculator has that function, it should not be taken to the examination hall.
I see.
Right.
Right.
So you're taking a risk, right? So if you're taking a risk.
Yeah, yeah, that's true.
So Harry, can you please summarize the solution of this particular question which we just did?
Yeah, so it's quite lengthy and it's obviously a lot of marks, but as you do them step by step, it's actually quite straightforward. Like you always say, so with my exam board, they kind of help you through it. So part A, using calculus to find the x coordinates, we simply just did the first derivative because we can see from the graph that points A and B are the turning points, critical points, local maximum, minimum, so many values, so many ways of saying it. But anyway, the gradient at those points are 0. So we know we just need to make the f dash x as 0. And then once calculating that, you straight from there, you get your x values. So we plotted them on the graph to see just visually how it would look. Then part B, they're asking about the second derivative in particular. So when you have to find the maximum, you have to do it by finding the second derivative and then substituting the value of 2, which is the x coordinate at A, into the equation and showing that that value is less than 0. So therefore, it is a maximum. And then part C, it was just simply finding the integral, which just using all those power rules and everything, just working through them. And yes, the plus C is critical, just adding that on the end because the graphs can move up and down and shift. So, and then finally part D, calculating the area of R. So what we did was we saw that between 0 and 2, it's everything under the curve. So we can definitely use integration and find that area. But then from 2 to 10 over 3, we saw that there was a right angle triangle. So we simply just found base times height divided by 2. And to find the height, we substituted the value of 2 into the main equation and found our y coordinate for A, okay, and then calculated. Yeah. But if you had another question that wasn't that straightforward and you didn't have a beautiful right angle triangle, then you would have to do the method that Sir said, where you have to find the tangent.
We know the 2 points. We know now the 2 points. We found the y value, which was 16 in this particular case. Sorry, height was 16, right? No.
Yes, it was.
Height was 16, correct? So you know this point, which is 216, correct? And we know the other point, which is 10 by 3. Using these 2 points, y2, you could find the equation of the line, and then put that in the integral from 2 to 10 over 3, find the area using integration. Add the 2 areas to get your result. However, you're going to get the same result. Is it okay?
Right. Okay, I'm going to try that.
Then make sure. Write down the units, unit square. Very important in all these questions. So I hope the steps are clear. But do your calculations. We might do sometimes wrong calculations to check your results, right?
Okay. Yes.
Let's move on and take the last question of the day. Can you share another question on logarithms now?
Yeah. So.
Okay. Can you please read this question?
Yeah. So part A, show that log base 4 3 equals to log base 2 root 3.
Correct. So how will you do this question?
So because the right-hand side, because this is a show that question, we're trying to get the answer on the right-hand side. So between, when you're looking at it, we have log base 4 on the left-hand side. So we want to make sure we have to change the base to 2.
Correct. So do you remember the change of base form?
Not really, no.
Okay, so if it is log of ax and you want to change the base to b, let us say, then it is log of bx over log of ba. So you change the base, right? So let's do this change of base formula on the left-hand side. So let's begin with the left-hand side, which is log of 4 of 3, right? So when you change the base, it becomes log, we want it to be 2 of 3 divided by log 2 of 4, correct? So let's find its value, which is log 2 of 3 divided by log 2 of 4 is 2 square, correct? which is 2 now. So which is half of log of 2 of 3, right? Now you can use the power rule, correct? Which
Oh,
is equals to log of 2 of square root 3. 3 to the power of half, which is square root 3, which is right hand side. Is that clear to you?
yeah. Yeah.
So that is how you're going to do part A. Is it clear?
Oh, okay. So I think so that whole part was just remembering the change of base formula, otherwise it's not possible to solve.
It's slightly difficult. No, it's slightly difficult, but change of base formula really helps.
Yeah, definitely. Okay, cool.
Next
Part
part.
B. Hence or otherwise solve the simultaneous equations 2 log base 2 of y equals log base 4 3 plus log 2 x.
So that is
Where
how you're getting help, right?
because it's the rule.
Hence or otherwise solve the simultaneous equations. You're given two equations. The first one is 2 log to the base 2y equals to log to the base 4 of 3 plus log to the base 2 of x. And the second one is 3 to the power of y equals to 9 to the power of x. Given that x and y are positive, right? Okay.
But we know that
Yes.
log base 4 3 equals log 2 root 3. So we can substitute.
Yes. So we'll do that. So log to the base 2 of y equals to, we are substituting log to the base 2 of square root 3 for log to the base 4 of 3, and then we'll add log to the base 2 of x. This is one equation. The other one is 3 to the power of y equals to 9 to the power of x. 9 is 3 square, right?
Yeah.
So it is 3 to the power of 2x. Is
2x.
that clear? So that gives you y as equals to 2x. Is this clear to
you? Yeah.
So now we can substitute this value of y with 2x.
Oh, yeah.
So we'll solve further. So we get 2 log to the base 2 of 2x.
2x.
Equals to log to the base 2 of square root 3 plus log to the base 2 of x. Is that clear to you? So now you have same base, one variable. So we got, that is the major part, right?
So same base and one variable.
One variable. Now you can say that this part is 2x to the power of square, right? So log of, correct?
So log of,
power, right? And here it is log to the base 2 of, multiply the two things, right? Square
root 3x
times x. Is that okay?
So x root 3, yeah.
So you need to now solve the equation 4x squared. We'll bring all the terms to one side, minus square root 3x equals to 0.
Oh, so you know the logs are there, they basically just cancel.
No, I mean log of a is log of b, a and b are equal, right? So we are using this log. So we can write here 2x squared equals to square root 3x, correct? Now we are bringing all the terms to the left hand side. We can take x basically factor, correct? So we get 4x.
But the logs cancelled, right? In that equation, because of the same base.
We don't say cancel. If I say log of 7 is equals to log of b, then b is 7, right?
Oh, because of the way logs work. Okay, yeah.
So now you bring it all to one side. So you get 4x squared minus square root 3x equals to 0. Take x common. So you get square root 3 equals to 0. So that means either x equals to 0, which is not the case. They are positive, or x is equals to square root 3 over 4. Is that clear?
Oh, yeah.
So the positive answer, of course, when you have log to the base 2 of x, we should write here, that means x has to be greater than 0, right? That is a restriction.
Oh, yeah.
So they don't really have to write that this is positive. You have to derive that directly. Correct?
I see. Yeah. And then we need to take our value of x and find y.
Correct. So we get x equals to square root of 3 plus 4 in this particular case.
Yeah. So the value of y would be 2 root 3 over 4.
Good job. So we have to find the value of y also, which was 2 root 3 over 4, which
can cancel.
over 2.
Yeah, root 3 over 2.
Root 3 over 2. Correct. So we have both the x and y values. We say x is equal to
root 3 over 4. And y equal to root 3 over 2.
perfect. So that is how you're going to solve this equation. Is this clear to you?
Yes, yeah. So first part was using log rules and changing the base formula and then solving. And then part B was the moment you see, like in the question before you even start, the fact that it says x and y are positive, we know that both x and y have to be greater than 0. So we write that restriction down, and then we followed through using all the log rules at this point. I feel like it was even indices rules as well. When we had 3 to the power of y equals 9 to the power of x, we know that 9 is 3 squared, and then we can work from there, getting y as 2x, substituting the value in and getting the both values of x and y.
Perfect, perfect. So let me clear the screen, and so we'll close the class here. I'd like you to summarize today's learnings about this solving this mock paper for you. How was it, and how do you summarize this?
Yeah, so it was definitely super helpful because I feel like my mind has to keep transitioning from topic to topic. And I feel like I'm starting to get a bit of a flow, starting to understand different ways to approach a certain question. So today we went through logs and exponentials. We went through circles. What did we? No, we didn't. Sorry. No, calculus, I mean, integration, indice work as well. Kind of, and even within questions, like you're doing a bit of trig, you're using lots of rules and things. So I think following through with all of that was super helpful, and just understanding the concepts and like the key things with integration, like just the plus C and stuff. Knowing those things is just really important, because at this point, because like you said, our exam paper is designed so that it kind of follows through, and then so you don't want to be losing those 1 marks, which are really easy to obtain. So yeah, that was really good. Thank you, sir.
Great. So we'll end the class here, and let's continue learning. Thanks.
All right. Thank you so much, sir. Bye. Have a good rest of your weekend. Bye.